This is Chapter 18, Example 3, and what we have here is another problem using addition here, just use it in a different way. Let's figure out the interface of this thing. So this is going to be, it has two 10-bit inputs, which are A and B. The outputs are going to be unchanged A or unchanged B. This also 10-bit, and we'll call it result. Key in this problem is we've got to make it work for all possible values, which means somewhere in there, if I'm adding B plus 5, that may end up overflowing the 10-bit range. I need to, somewhere in there, switch to 11 bits. Even though I'm outputting 10 bits, the interior circuitry is going to be working with 11 bits. So what I need in this thing, I see two additions in there, and so I need two ripple carry adders. So the thing that's going to add is A and B, and to A it's going to add 2. We'll just say 2. Good enough. We don't have to worry about the head or the binary. And here, this is a 10-bit hard-coded to 5. Okay, so that's going to give me my A plus 2 and B plus 5. And so what I'm going to do with those values is compare them, but it's not going to be a 10-bit compare. It's actually going to be 11-bit compare. So what I need to do is append that carry out to the 10-bit result and make it 11 bits. And these 11 bits is what I'm going to compare. So there's the comparator sitting there. I have to make a problem calls out for a greater than or equal to. And lastly, there's a choice being made. The decision to either output A or B. These are 10-bit, 10-bit. Here's my 10-bit output. Here's my result. I have to do one more thing here. I have to control this mux. Control this mux is going to be a function of the comparator. And let's see how I'm going to do this here. It's a question of, I know I can connect greater than or equal with an AND gate, but I'm pretty sure I can use the less than input to make this circuit work. So as is, we'll check this out, and then I do take my typical guess on what it's going to output here. If less than is a 1, that means A is less than B. So that means A plus 2 is less than B plus 5, by the way I have it set up. So that means if A is less than B, it's not greater than or equal to, well, B plus 5. Which means, so this case when LT is a 1, I need to choose the B input to come out on that. And so once again, I've guessed wrong on it. And this is going to be 0 and 1. So we'll check that again. If the input to A, which is the A associated input, is less than the other one, the LT is turned on. In that case, I want to output B, which is what I have connected there. And I'm going to call this done. I believe this is right. The last thing we want to do here is figure out how this is controlled. Here is a mux. Control input is connected to this LT signal, which is an internal signal. So this circuit has internal control. This problem, certainly a lot going on in this problem. It's not a trivial problem. There's a couple different things going on. Read through them, grind through them, and you will get the answer.